Hello friends, I welcome you all to my channel. Today we are going to learn a very important theorem, that is Chinese Remainder Theorem. It is a part of number theory and it is a very important components of the Olympiad maths tutorial. So we'll learn what is Chinese Remainder Theorem and how we can solve the Olympiad maths problem using this theorem. So let's begin. What is Chinese remainder theorem? If in a set of equations, each equation has a different number, say n1, n2 up to nr, and these numbers are all relatively prime to each other and also have some numbers, say a1, a2, a up to a3 up to ar, then there is a unique solution of this all these equations, that is, if we call it x, that satisfies all the equations at once. This is the definition of remainder theorem. Now, now let's state this theorem mathematically or analyze it. Let n1, n2, n3 up to nr belongs to n natural number system be pairwise relatively prime. First condition is they should be relatively prime. For any a1, a2, a3 up to ar belongs to integer, the solution set of the system of simultaneous equation congruences, if there are many congruence statements, x is congruent to a1 modulo n1, same x is congruent to a2 modulo n2, x is congruent to a3 modulo n3 up to x is congruent to ar modulo nr, then we can solve this problem, or we can find x as it consists of unique congruence class modulo n, where n is the product of all small n1, n2 up to nr. Or this x is calculated by this formula. This is summation of ai multiplies ni multiplies xi, and the sum of all this product starting from 1 n is equal to 1 to r. How ni is calculated? Capital Ni is calculated by n, which is a product of n1, n2 up to nr, by individual ni. And how xi is calculated? It is your ni xi is equal to congruent to 1 modulo ni. So it seems to be difficult, but when we go for the problem we solve, it is not that difficult. So let us proceed to a example. So I have taken an example of x, as I have taken three equations simultaneous congruences, and we will write the algorithm or steps of how we will find out, so that it will be easier for you. The three simultaneous congruences are given as x is congruent to a1 modulo n1, x is again congruent to a2 modulo n2, x is congruent to a3 modulo n3. We will find x. So step 1, first we'll multiply just n1, n2 and n3. That is denoted as capital N, because at last we'll find x as 1 modulo n. So step 2, then we'll find capital N for each cases, and the formula will follow that n1 is equal to capital N upon small n1, n2 is capital N upon small n2, or capital N3 is equal to small n3. That means ultimately n1 equals to your n2 into n3, n2 is equal to n1 into n3, and n3 equals to your n1 into n2. because n is equal to product of this. Step 3, you will find value of x1, value of x2, value of x3 with three equations. N x1 is equal congruent to 1 modulo n1, n2 x2 is congruent to 1 modulo n2. This step is very important, and n3 x3 is congruent to 1 modulo n3. Now, after getting x1 and x2 x3, as I told, this step is important and this step is slightly critical. Now, step 4 will get all the sum of a and x, that is nothing but your a1 n1 x1, a2 n2 x2, a3 n3 x3 modulo n. So let us go to an example. So there is a question: solve the system of congruences x1, x is congruent to 1 modulo 3, x is congruent to 2 modulo 5, x is congruent to 3 modulo 7. We have to find x. So solve system of congruence means find x. So first we'll check that whether this n1, n2, n3, they are co-prime or not. That means we have to see pairwise that 3, 5, 1, 5, 7 and 3, 7 are co-prime pairwise. That means I can apply the remainder theorem. So now identifying what will be A1. A1 equals to 1, A2, 2, A3, 3, N1, 3, N2, 5, N3, 7. This is your N1, N2, N3. The next is to find out N. N equals to N1, N2, N3. So here if we multiply 3 plus 5 plus 7 equal to 105. So first step is complete. Next, coming to second step. Second step is finding individual capital N. So Ni N1 equal to N by small n1. So it will be 105 by 3. That will be 35. Or directly we can multiply 7 and 5. Similarly, N2 equals to N by N2 equal to 105 over 5. This is N2. It will be 21. And N3 equals to 105 by 7. That will be your 15. So I'm writing N now, N individual, that is 35, 21 and 15. So second step is complete. Then coming to third step. Third step is your N1 x1 is congruent to 1 modulo small n1. That means applying here, I'll get 35x1 is congruent to 1 modulo 3 because n1 is 3. So this step you have to find out. That means think critically. What does it mean? I have to think of what should be the x1 so that product with 35, when it is divided 3, it leaves remainder 1. Repeat, x1 will be by trial method. I'll think of what is the value that when it will be multiplied with 35 and divided with 3, I'll get a remainder 1. So it will be 35 multiplied by 1. It does not leave remainder 1 when divides with 3. But if I'll multiply 2, 35 2 times is 70. So 70 when divides with 3, it leaves 1 remainder. So this implies that x1 is equals to here 2. So I am making table here x, it is 2, first one is 2. Next, in the same way, going for n2 x2 is congruent to your 1 modulo n2. So it implies that your 21 x2 is congruent to 1 modulo 5. So starting from 1, 21 into 1, 21. When it divides with 5, it leaves remainder 1. That means x2 equals to 1. And for x3, n3 x3 is congruent to 1 modulo n3. That means your n3 is 15. 15 x3 is congruent to 1 modulo 7. So it's also easy to find out. 15 into 1 multiply 1. When divides with 7, it leaves remainder 1. So x3 is also 1. So 2, 1, 1. Then what to find? X. X is equal to summation of your a1, n1, x1 plus a2, n2, x2 plus a3, n3, x3 whole modulo n. So let us multiply all the things. That means I'll multiply a1, x1, n1, x1. So x is congruent to, not equal to, congruent to 135 into 2 plus a2 and 2 x2. 2 into 5 into 1 plus a3, 3, 15 and 1. It's not, sorry, it is not n2. I made a blunder here. It will be 21 only. It is your 3 into 15 into 1. I'm sorry. So whole modulo and n is how much? N is equal to 105. So x is equal to, this is 70 plus 42 plus 45 so 105. So if we take the sum, how much it is? It is your 157 below 105. That means if we divide 157 with 100, 105. What is the remainder? Remainder is your 157 divided by 105. 52 is the remainder. So 52 is the answer here. X equals to 52. So solution is X is equal to 52. I hope it's easy for you. Now you feel easy. Next question. Next question, I have taken only two components, not three. So x is congruent to 3 modulo n. X is congruent to 9 modulo 13. That means a1 is equals to your 3, a2 is 7, and n1 is 9, n2 is 13. And you will see that 9 and 13 are co-prime. So I can use this remainder theorem. So first I'll get n is equal to n1 into n2, that will be 117. Next I'll get individual n, that will be, so it is, obviously it will be 117 by 9, that will be 13, n1 will be 13 and n2 equals to 9. When two are there, it is easy. Now coming to x1, x2, x1, n1, x1 equal to your 1 modulo n1. That means 13 x1 is congruent to 1 modulo your 9. 13x1 is 1 modulo 9. Then how to find out? Just let's think. It will be 13, 1 is 13, 26, no, 39, no, 52, no, 65, no, 37, 36 times 78, no, 13, 7, 91, that time it will be. So that means x1 is your 7, because 13, 7 is 91. When it divides your with 9, it leaves one remainder. Next is n2, x2 is congruent to 1 modulo n2. That means your 9x2 is congruent to 1 modulo 13. So 9, 2 times 18, 3 times 27. Yes, 27 gives us 27. When divides with 13, we get remainder 1. So it will be 3. 9, 3 times 27. So x2 is equal to 3. So 7 and 3. Now I'll multiply a1 and 1, this. So x equals to 3 into 13 into 7 plus 7 into 9 into 3 modulo, what is n? N is equal to 117. So x is equal to, now you will multiply, it will be 273 plus 3 9 21, 289, 189, 117. So if we'll add this, equals to your 462 modulo 117. When 462 is divided by 117. Divided with 4 or 3, 3. It will be 3, 5, 1, 1, 1, 1. So 1, 1, 1 is the remainder. So the solution is 1, 1, 1. Now a question, a number when is divided by 3 leaves remainder 2, when divided by 4 leaves remainder 3, and when divided by 5 leaves remainder 4. What's the number? So it is given in the word problem. So we'll frame the equations. We'll write let the number be x, and x is congruent to 2 modulo 3. That means when it is divided by 3 leaves remainder 2. Same when it is divided by 4 leaves remainder 3, and when divided by 5 leaves remainder 4. So there are three equations, three congruences, not equations. We have to find x. Since 3, 4, 4, 5 and 3, 5 are pairwise prime, we can apply Chinese remainder theorem. First we have to mention why we are applying this one. Next, after the framing equation, we'll write your what is a1. A1 is 3, a2, then a2 is 3, then a3 is 4. And what about n1? N is 3, 4, 5. First I'll go to step 1. I'll find n. N is equal to your 3 into 4 into 5. That will be 60. Now getting n individual, n1 will be certainly 60 divided by 3, it will be 20, n2 equals to 60 divided by 4, that will be your 15, and n2 is equals to 60 divided by 5, that will be 12. This will be 20, 15, 12. After getting n1, n2, n3, second step is complete. Then we'll go to third step. That will be n1, x1 is congruent to your 1 modulo n1, or I'll write your 20x1 is congruent to 1, 3. Now if we'll go on calculating, 21 into 1, 20, when divides 3, does not leave remainder 1. Then I'll go for 2. 22, 20 multiplies 2 is 40. When 40 divides 3, it leaves remainder 1. So x1 equals to your 2. Next is second one. So it will be 15x2 is congruent to 1 modulo 4. 15, 1, 15, 15 into 2, 30. 15 into 3, 45. 45 when divides with 4, it leaves remainder 1. So x2 is 3. And your third congruence will be 12x3 is congruent to 1 modulo 5. So 12 divided by 5 does not leave remainder 1. 12 into 2, 24 does not leave remainder 1 when divides with 5. 12 into 3, 36 when divides with 5 it leaves remainder 1. So this gives us x3 is equal to again 3. So writing x here, it will be 2, it will be 3, it will be 3. Now coming to n. So n is equal to a1 n1 x1 plus n2 n2 x2 a2 n2 x2 a3 n3 x3 modulo n. Then statement for last. So it will multiply 2, 20, 20, 3, 15, 3, 4, 12, 3, and we'll take the sum. So n is equal to 2 into 20 into 2. It will gives you 80 plus 3 into 15 into 3, 135 plus 4 into 12 into 12, it will be 144, and modulo n is equal to n we have got 60. So this is equal to, if we'll add it, this equals to 80 plus 135, 144. It will be 359. 359 modulo 60. So when we'll divide 359 with 60, 65 times 300, so 59 is the remainder. So n is equal to 59. So 59 is the solution. Not n is equal to, it is x is equal to all the line. It's a blunder. X equals to x equals to x equals to. So x is equal to 59. Thank you for watching. Please keep on watching. Gradually, we will be continuing some more questions from Math Olympiad. So, continue to watch. Thank you.